Morning, everyone. Uh, in this week's session, we're going to continue with a little bit of that work that we sort of stopped halfway through last week. If I remember rightly, we were modeling up that linkage part. So it would be, if I just share my screen, it would be that drawing that I seem to remember that we were trying to replicate. And we got a certain way through the actual task of doing that. So correct me if I'm wrong, but we'd sort of modeled the majority of the body of this. We'd done the lower pipe and we'd done the upper pipe. We sort of started the job of creating the sort of spine that links them together. And the various groups that I take for this module, we'd got to different points sort of success of creating that spine. So I think some of the groups moved on to creating this fillet feature, and some of the rest of the groups were still, if I just load up one of my copies of that, let's have a little look. 2021 lessons. So something like this one, I believe, is where we left it, where there was possibly a bit of a discrepancy between the bottom of the spine feature that we just created and the lower tube. There was a sort of wedge of material that was missing. So I think more or less all the groups got to kind of that sort of stage. And I think at the time I kind of said, well, the sketch that we've created for this spine feature, or this piece of material that's joining these two tubes together, because we'd sketched it on the right plane there, we were actually looking at this lower tube like that, and we were creating a horizontal line there to close the sketch off, but that horizontal line was corresponding to the highest point on the tube there. And obviously, as our extrude feature extrudes outwards from the sketch, the tube kind of drops away from it. So the tube is obviously a cylinder. So it's kind of dropping away all the time. So you end up with this piece of material, or this wedge of material, that's actually missing. So I think the first thing that we'll do is we'll drop back into the sketch for that feature, for that spine feature that we created with an extrude, and we'll kind of address that. And I think what we'll do, it should be more or less obvious, we'll lower this bottom edge down into the tube, so there's overlap then between the new feature that we're creating and the existing feature, which is the tube. And then what the system should do, which is its default behavior, is it should essentially weld them into a single piece of material. So it will merge them together into a single block of material. And I think I talked about with most of the groups the fact that that's kind of the default behavior of the system. If two features kind of overlap each other or touch each other on any of their faces, the system will kind of merge them into a single piece of material. And just to investigate that a bit further, you can see with the upper tube, because our new feature does in actual fact touch the upper tube, we created that arc in the sketch that sort of matches the outside diameter of that tube. The system has actually welded those two together into a single block of material. So you can see I've highlighted it in blue on my screen there. So yeah, that's the default behavior. But then if you don't get positive overlap, which we haven't got here, we've got the lower face of our new feature, this flat face, just theoretically touching the tube at it's an infinitesimally small contact patch. So the more you zoom in using this graphics window, the smaller that patch gets. So essentially they're not overlapping, they're not touching. So the system has refused to merge them into a single piece of material. So we're now going to correct that. We're going to go into the sketch, modify the sketch, create some overlap there, and then the system should merge them together. Now what we're going to find is the system has set some options in that extrude that mean that we have to do a little bit more work to get them to merge now. But it's worth knowing how to correct these little problems that you may sort of encounter. So the first thing, let's go into the sketch. So in order to edit a sketch which is being used to create a feature, you just find the feature over here in the feature manager. So it's this last feature, this Boss Extrude 3. Click on it, and then the second icon there on the top line of icons is edit the sketch. The first one is obviously edit the feature itself, which we're going to do in a second, but we want to edit the sketch first that's actually being used to create that. Then, as we covered, I think a couple of weeks ago, I've now set my system to auto-rotate my view round, and I'm sure I showed everyone how to do that. So that's why my view is now looking square at the sketch, or at 90 degrees to the sketch, or as the system calls it, normal to the sketch plane. So what are we going to do? I think the first thing I'll do is delete that existing horizontal line at the bottom of the sketch. So I'll just click on it and hit the delete key. Someone asked in one of the other sessions, they were on a Mac and they said, I don't have a delete key. And I think they got round, if anyone's using a Mac and using emulation to run SolidWorks, I think it's Shift and the backspace key. So yeah, I'll give you the benefit of his knowledge. So something's happened there. So you've got to be observant. The lines here, the arcs that we created that were previously fully defined, have now become underdefined as soon as I deleted that bottom edge. So because I've done this sort of tutorial a few times this week already, we've seen this already. So what has happened is the endpoints of these arcs, so that one and that one there, weren't actually locked onto the top edge of the tube itself. They were locked onto that horizontal sketch line that we'd then locked onto the top edge of the tube. So when that horizontal sketch line disappears, they're not attached to anything. They don't have a coincident relation with anything in particular. And you can investigate that further by clicking on them, holding the mouse button and trying to drag them out of position. And you can see you are able to drag them out of position now. But that's an easy one to fix. Whilst you're dragging them, if you drag them back over the point that you want to lock them to, the system should auto add. I'll try that again. It's added one of them. So you can see now mine's added a coincident relation with that vertical edge. So all I need it to do now is add one to that horizontal edge. So again, I'll click and drag, see if I can make it do the job. It's still not working. All right. Well, there's more than one way to do this. The second way that we can add relations, and we've done this time and time and time again, is select the entity that we want to add the relation to, hold down the control key on the keyboard, select the other piece of geometry that we want to relate it to. So in this case, it's that top edge there that's highlighted in orange. Click, and then we can add a coincident between them. Don't click on that one because that's a midpoint. So coincident is what we want. So you can see I've fixed that one. Now I'm going to hide the planes when I fix this one because that vertical plane there is kind of getting in the way. So I'm just going to temporarily hide the planes. And I'll see if I can get this one to do it using the drag method. So I'm just going to drag it to the point there and then let go. Yeah, it doesn't seem to be behaving itself too well this morning. Let's see if we can make it work. No, I'm going to add that one in manually as well. So again, it's done half the job there. It's locked it onto the top edge for me, but I also want to lock it to this vertical here as well. So I've got the point selected already. I'm going to hold down control and I'm going to select the vertical edge there and just make them coincident with each other like that. So yeah, there's a little bit of correction and a little bit of sort of fixing the sketch after we delete that lower line. So the next kind of decision is, we know we're going to put a horizontal edge down here and two extra vertical edges to link to that horizontal, but how deep into the pipe do we want to kind of draw this sketch, which is a sort of valid question. And probably the smartest way to set this sketch up is not to give it just a a dimensioned depth that it kind of overlaps with the pipe. But to make it overlap to the point where it meets the inner kind of internal bore of the pipe itself. So if we sketch this vertical line here so that it meets that inner cylinder or that inner bore diameter of the pipe itself, and then put a horizontal that coincides with the inner bore along there, and then put another vertical to join back up with this end of the sketch, then we can be sort of safe in the knowledge that if this design ever changes and that internal bore gets smaller or increases and gets bigger, that our sketch for this spine will auto adapt to that. It will actually change its size and scale to adapt to the changes that we've made to the pipe sort of section there. So that's probably the safest way to set this up. So I've just rotated sideways there, and I've switched on wireframe display. So normally we have what's known as shaded with edges as our default display method. But I've switched on wireframe because that allows me to see through the lower pipe and see that inner wall as I'm creating my sketch. So the way that you do that is that icon at the top. And there's various methods to display the model. There's just shaded or shaded with edges or various other kind of wireframe-esque ones. But it's the bottom one that we want, where every edge on the model is visible, whether it's at the other side of the model that we wouldn't be able to see if we were looking at it, say, in real life, and all the edges on the side that we are actually viewing the model from as well. So I'm going to rotate my view back round to be normal to the sketch plane, because that's the most kind of useful viewpoint to actually create these edges. So normal to, there we go. And I'm just going to get the line tool and put a vertical line down that edge there to that point, and then keep sketching with my line tool and put a horizontal edge to there. And again, I've still got the line tool active, put a vertical edge back to that point there. And that should close my sketch up again. And we've done what we sort of set out when we came in here. We've sort of sunk that extrude feature down into the pipe. So there's definitely going to be some positive overlap between the two pieces of material now. So normally you would expect the system to now, when we OK this sketch, to unify these two pieces of material into a single sort of solid whole piece of material, as it did with the upper pipe and the spine. So let's see if it does that. So we'll exit the sketch. We'll press the blue exit sketch icon. We'll turn our view back to shaded with edges, which is our sort of default view setting. And then if we rotate around, it looks as if there's something odd happening there now. So if I zoom in a little bit and then just click on the end face of this pipe so that I can highlight it in blue. And then with that highlighted, if I sort of move my view around, you can see what's referred to as graphical tearing. And that's occurring because it hasn't actually unified these two bits of material into a single piece. So what's essentially been or attempting to be shown there is that the flat end face of that extrude that we just created, so that face there, is trying to occupy the exact same point in space as this big flat face on the end of the pipe. And the system's struggling with that, which is why you kind of see the grey face jumping through and being shown on some angles there, and the blue face sort of jumping ahead of the grey face. So yeah, there's something wrong there is the bottom line. And we can double check that by, if we look up here, there's a little folder that says solid bodies, and it should have a brackets 2 after it. What that's saying is there's not one unified body of material in your part, there's actually 2. And if you click on them, you can see them highlighted. So we've only half fixed the problem. We fixed the shape of the sketch, but there's an option in this extrude feature that got switched off, and we now need to go back in and switch it on. And the reason it got switched off is when we originally made that feature, it didn't overlap with the lower pipe. So the system automatically switched this option off that we're about to correct. So we're going to have to edit the feature this time. So we're not editing the sketch anymore. We're going to edit the spine feature. So find the feature that you want to edit in the feature tree or the feature manager. Click on the first icon, which is edit the feature rather than edit the sketch. Now we get access to all those setup options that we had when we were creating this feature. And there's two that we want to check the status of in here. Is the merge result option ticked? Yes, it is. So that's not the issue. If that was unticked, the system wouldn't merge this feature into any of the other features. So that was not the problem because that was actually ticked. Lower down the page, I've actually just done something there that changed what was lower down the page. So if you haven't messed with this feature here, what you'll be looking at the bottom of the page is feature scope, selected bodies, and the system will have auto-selected just the upper tube to merge with. It won't have selected the lower tube. So what we normally do with this is just switch it back to merge with everything that you overlap with, which is all bodies. So feature scope. So yeah, with those two options, switch to these settings, merge result and merge with all bodies. Then anything that this feature overlaps with, it will get merged together with them. So that's the setting that we want. And that only got switched because when we created that initial sketch, it wasn't overlapping with the lower tube. So the system kind of plays with those settings to make the feature work in some way. So anyway, we've merged them together now. And what I've got on my readout here is that I now have a solid bodies. I now have a single solid body in this part. So the whole of this part is essentially made out of the same block of material, which is what we want. You probably won't see that on your interface because I've set my SolidWorks up to always show this folder. Whereas I think the default in a new install of SolidWorks is that when you only have a single body, this folder is hidden. It disappears because you don't need to really be aware of it. It only appears when you get more than one body actually in a part. So you will have been able to see it before, but then when you corrected the problem, it will disappear by default. So let's try and progress on to the next feature. Let's have a little look at what we're going to tackle next. So I think what we'll go for in terms of the workflow is we'll put that large fillet on. So there's a large fillet there that kind of bridges the gap between this lower tube and the side of our spine feature that we've just created. And if we want to know what size it is, it's kind of annotated there, 2 times 50mm radius. So it's a 50mm radius fillet, and because there's 2 of them, we can assume that this one on the other side of the part is actually 50mm as well. So we're going to put those 2 on. So that should be relatively easy for us. So as we said when we kind of used the fillet tool a few weeks ago, it is available up there as an icon on the features toolbar. Features toolbar, fillet feature is there. But by far the easiest way to activate it is just click on the edge on the model that you want to apply it to. And it appears there in the quick access toolbar as well. So click on that. You should get a preview of what it's looking like. That's too small. So we will double click on that 10mm value and put our 50mm in and press enter. And then we want to apply it to the kind of mirror image of that edge. So I'll rotate around and select that second edge as well. And again, if you're not seeing the double preview there, so a preview in yellow of each edge, it's probably because you've got partial preview selected there. So partial or full preview, depending on which one you want to see. So that looks okay, so we can OK that. That's an easy one to put in. Then I think we'll tackle those red fillets as they're highlighted on the drawing that we're working from. So you can see the kind of logic of using colour on this drawing, which is moderately kind of unique on drawings. A lot of the drawings that you see are just line drawings, but there's some justification for using colour on this drawing, and that justification is all these fillets which are of radius 4 have all been coloured in a specific shade or a specific colour to allow you to pick them out easily on all the views. So the colour in this and the shading in this instance is actually there for a reason. So all the red geometry there is 4mm fillet feature. So let's put that one in. So again, I'm going to initiate this by just clicking on an edge. So I'm going to click on that edge around the edge of that upper tube. Click on the fillet feature. You won't now get a preview because it's way too big for the actual space that's available here. So I'm going to shrink it down to 4mm. Then I should get the preview. And it's just a case of working our way around applying this to all the various edges that it's actually applied to on the drawing. So it's applied to that little internal one there. So I'll click on that one. And then just so I don't forget, I'll do the mirror image of those two on the other side of the part. So I'll do that one and that one. So we've got all the ones that are kind of centered around that upper tube shape. We've also got it applied to the top edge of the spine there. So if I click on that edge, now that will automatically run a fillet all the way around all the neighboring edges there. And the reason it's doing that is that every single edge on that chain of edges there is tangent to its neighbor. So the fillet by default will run around all tangent edges. So that's why it's kind of saving us time there. So we don't have to click all the way around to get all those edges. And the same will happen when we select this lower edge here. So we can click on that edge. And again, all the neighboring edges there are all tangent to their neighbor. So it will just keep running round as long as those edges continue to be tangent to each other. And I mean, if we delve back into how we kind of created this shape, we ensured that the upper arc there on that sketch was tangent to the lower arc. And we also ensured that lower arc was tangent to that vertical face. And we also ensured that upper arc ran into the edge of that tube and it was tangent. So we've kind of designed that into the actual part itself, that all these edges are all tangent to each other. So when we've got them all selected, we can OK that fillet feature, have a little look at it. Again, little differences between what you've seen on my screen and what you're looking at. You may not have this dashed kind of effect at the edges of your fillets. Yours may be shown in solid unbroken lines, a little bit like the line that kind of marks the edge of this tube. Don't worry about that at this point. I was doing another tutorial earlier in the week, and it was necessary for me to sort of modify my system slightly, so I was seeing these. But you may, I'm a little bit hazy on what the default is when you first load SolidWorks, so I've changed that backwards and forwards so many times that, yeah, yours may look exactly like this, or it may look slightly different, so don't worry about that. So what are we going to do now? Let's have a look at applying that actual red color to this fillet feature specifically. So you can apply colors and appearances to give them their correct name in SolidWorks. You can apply appearances to either the part as a whole, to specific features, to specific faces on the part, or to kind of combinations of all of those. So currently the part has a single appearance applied to it. And if you want to click, I'll try that again. I always make that mistake. If you want to click on that little, it's known as a rollout arrow there. So up in the feature manager to the sort of top right, there's a little arrow pointing to the right. And if you click on that, you get this extra rollout at the side. And the reason I've done that is at the top level there, the part level itself, so the entire part, is coloured currently in this default grey colour. And you can kind of see that represented by that sphere that's coloured in grey. So we don't want to apply a colour to the entire part. We just want to apply it to this fillet feature. So what I'm going to do is click on the fillet feature, and then it's that icon there to edit the appearance of something. And in this case, it's the feature that we're going to edit the appearance of. So then when I click on that, the system's basically offering me the choice. Do I want to change the appearance of the entire part, which is currently grey, or do I want to change the appearance of a specific body, which we now know we only have a single body in this part, so that essentially means the same thing, or do we want to change the appearance of the feature that we clicked on only? So in this case, it's the feature only. So click on the fillet from that list, and then we just get sort of a standard color palette that you see in a lot of sort of common graphics programs. You can drag around the whole palette here and come up with a specific shade, or you can just pick a default shade from this sort of range of default colors at the top. So I think we'll just have that default bright red. I think that's what the original drawing was set up with. And then you should get a preview of what that's going to look like. And if you're happy with that, click on OK, and we've okayed that. And you can see in our kind of pop-out panel at the side now, the fillet feature has a specific color applied to it, so you can see that there. And if you needed to go in, you could click on that and go to appearance. Let's say you want to change it to a green color. You can do that. So you get the idea. You can apply that per feature, the actual color. So we've done that. There's one last bit of this design that we kind of need to add before we get on to producing the drawing, and it's this section here. So the thought here, although it's not indicated with the note, is that this is what's known as a keyway, and there'll be some form of shaft that sits in this lower internal bore, and that shaft would probably have a matching keyway machined into the shaft. And what you would do is just slide a key, which is a sort of little block of material, in between the two, and it would lock the rotation of this component and the shaft together so that they couldn't spin relative to each other. They was kind of locked rotationally. So yeah, we need to put that feature in. So we're going to do it with an extruded cut, which should be relatively easy. And I think we'll place the sketch on this kind of front flat face of this tube feature. So extruded cut is the feature type. Where do we want to sketch it? We'll sketch it on that front face. The view should rotate round. What sketch shape do we want to use? I would say center rectangle, because from those drawings you can see that slot is dead center in relation to the actual tube shape itself. So I'm going to use the center rectangle because that allows you to drop a point initially in the center of the rectangle. So it's the one that we want. Center rectangle. If I hover above the origin there, you can see it's creating a dashed line down to the origin, which basically means you're directly vertically above the origin. In fact, what I'll probably do is make the planes visible again. That will be more useful for us. So I've had the planes invisible for a while. I'm going to bring the visibility back again by clicking up there. And the reason I've done that is it will then lock this center point of the circle onto that vertical plane there. So that's what I want it to do. So I'm going to click to drop the center, drag it into approximately the right sort of scale, so it's going to cut this keyway around about there. Then press escape because I don't need the rectangle tool anymore. And then I'm going to add some dimensions onto it. So click on Smart Dimension and do the width of the top edge there, which should be 14 millimeters, like that. And then if we have a look at the drawing, just to see how the height of it, if you want to call it that, is dimensioned, you can see there's a height, or there's a length dimension there from the top edge that we just clicked on all the way down to the furthest point away on this circular edge, which we've kind of encountered this before. That's not the default sort of way that the system dimensions to a circular edge. Normally it will try and dimension to the center point, but we've kind of experienced it when we did that slot shape on top of the tire lever. If you hold down shift before you click on the circular edge, you can force it to dimension to the outside edge of the circle. So that's what we're going to do. So I've still got the Smart Dimension tool active. I'm going to click on that top edge, and at this point I'm not holding down Shift when I click on the top edge. Now I'm going to begin to hold the Shift key, and then with it held, I'm going to click on the edge of the circle there. So that will allow me to get that specific measurement to the edge of a circular feature. And the alternative is, so I want to set that to 55, but just for example, I'll delete that dimension now and do it without holding the Shift key down, just to sort of illustrate what you get normally. So I'll click on the top edge without the Shift key held, still not holding the Shift key, click on the circular edge, and I get that to the center point of the circle, which is not what I want in this case. So you've got to hold down Shift if you want to dimension to the edge of a circular feature. And then, yeah, that should be 55. So we've more or less locked down the shape of this now. The only thing that's still free to move on this circle, so I'm going to investigate what that is I'm going to hit escape to get out the Smart Dimension key, drag one of these blue points. Yep, it's still free to move kind of vertically. So I'm going to try and use the old dragging the point onto the plane trick again, and let's see if we can get this to lock itself on. So I'm dragging the point, hover over the plane, let go. Yeah, so it's put a coincident relation between the two there. So that's kind of the behavior of the system. It kind of mimics how it behaves when you're creating sketches. So as you're creating a sketch or sketching lines, it's offering those relations to you by showing a little icon as you hover over something. You can kind of get it to do the same thing by dragging sketch lines around as well. And sometimes it works, other times you have to do it manually. But we know how to do both methods to add relations in. So yeah, that should be fully defined now. It's a closed boundary, so it's always worth doing those two checks. You can have a look at the bottom, fully defined. It's been shaded in, so it's closed, so we're happy. We can exit the sketch. And then I'll rotate my view so I get a better appreciation of what's going on there on the preview. And I think in this case, we'll use through all. So again, giving this particular feature a blind dimension is arguably not the smartest way of setting it up, because certainly from this design, I would say the intention of this keyway is that it always breaks through to the back face. So through all will achieve that, whereas a blind value is prone to not achieving that if the design of the part changes at all in the future. So through all, okay, and that's it. That should be the entire part finished. So the next step that we're going to go on to is we're going to attempt to recreate that drawing. So we're going to get a bit more practice on creating drawings, which we've done a little bit of already. But yeah, we need to kind of practice that workflow of creating our parts first, be they a copy of a part that we've been supplied a drawing of, or coming up with our own part designs a lot of the time as well. So modeling the parts is half the kind of workflow. And then when we've got the part models, producing things like drawings of them, engineering drawings to pass on to manufacturing or to pass on to quality assurance departments or to pass on to suppliers and subcontractors. So yeah, that's what we're going to practice. So the first thing that we're going to do is we're going to take a save of this completed part. So just click on that save icon at the top. You should have already named it because you loaded it in at the start of this session. So you can see mine's a little bit different. I've had to put a 3 on the end of this particular one because you're the third session in the week. So I've been keeping copies of this. Yours should just be called offset link because that's what it's called on the drawing. So with that part still open in the background, so don't shut the part down, what we're going to do is just jump straight into creating a drawing of the part that happens to be on the screen at this point. So this is a different way of creating drawings to the one I showed you before when we were doing the tile lever. In that case, I said shut the tile lever down and then we'll simulate maybe you coming into SolidWorks in the morning and you've modelled something the previous day and you just initiate a new drawing, and then you have to find the part on the actual hard disk. This is kind of the other way. If you've just finished creating the part, it's still on the screen, you can just go into the file menu at the top there and go make drawing from part, and it's just whichever part you happen to have active on your screen. So make drawing from part. It jumps straight into the drawing creation kind of dialogue, and then a quick glance back at the sheet that we're trying to replicate here tells us it's an A3 sheet, it's in landscape format, and this one in particular is a slightly modified ANSI A3 landscape sheet. So let's find that in the list. There it is, A3 ANSI landscape. And if you can't find it in the list, it's probably that you've got that box ticked, which filters the list down to just the formats that are available in your standard that you told the system you wanted it set as. So untick that list so you can see the full list. And A3 ANSI landscape, okay. It will create the sheet, but it will be blank at the moment. It won't have any drawing views on. So you can see it's created the sheet there. It's created the title block. It's put the name of our part in the title block. It's decided on a sheet scale as well. So it analyzes the part that we're about to place. And it says this is a sheet scale that will allow you to fit views of that part on this paper size. And it's put the border on there as well, which you can see on the ANSI sheets. It's quite useful, because you can reference a particular square on the sheet by giving someone a horizontal square reference. You can see they're all numbered here, and a vertical square reference. So if you're talking about something that's here on the sheet, you could say 4E, and whoever you were talking to would know which bit of the sheet you're actually talking about. So if you haven't clicked on the sheet yet, which I don't recommend you do at this point, then you'll still be able to see this rollout on the right hand side, hopefully, although somebody said they couldn't see that. But as soon as you click on the sheet, that disappears. So that is known as the view palette, and if you can't see that, I'll show you an alternate route to do what we need to do in a second. But hopefully you can all see that icon at the side, and that's known as the view palette. And it's basically the quickest and easiest way to place your initial views on the sheet. Now, the view that we want, if we have a little look at the drawing that we're working from, I would say that this is the kind of parent view on this sheet, because this is the view that view and that view have been created from. This view and this view are both projections away from this view. So the logic states that this view's got to go in first so that you can then project some views away from it. So this is kind of the parent view. This is the first view that we want to drop into our sheet. So back to the view palette, I can see it there. So this is why the view palette's quite a nice tool. When we were doing the tile lever, we were working over here and we had views that were just labelled as right and left and top and bottom and front and back, but we couldn't see what they look like in the menu. This allows us to just quickly see what those views are going to look like. So I know it's this one that I want, so I just left click on it, hold the left mouse button and just drag, and then drop it onto the sheet like that. So it's really easy method of getting views onto the sheet. And then the default behavior that the system then goes into is, as I move my pointer away from that view, it gives me projected views. And you can see the projection lines there, or the center projection line in grey, coming away from the center point of the original view. So what I'm going to do, I'm going to click to drop a view to the left of that one, there, and then I'm going to move above it, there, and then click again to drop a second view. And then I don't want to drop any other views. So if you can see there, there's a little icon next to my pointer that looks like a mouse with a green tick on the right button. So it's another time saver. It's just, instead of going to the top right of the screen and clicking on that green tick, I can just press the right button and it okays the operation that I was just doing, and it exits out of that operation. So yeah, there's always kind of multiple methods to do this same thing, but there's often a sort of shortcut that the system offers you rather than moving your mouse pointer around the screen too much. So it's trying to speed up your workflow. So we'll drop that 3D kind of isometric view up here, and then we'll kind of be done with actually placing the views on our sheet. At that point, what we'll do is we'll address the fact that none of these views are shown in their colored kind of shaded form. So we'll kind of tweak the actual setup of each view then. So we want to place a view up here, but this view has got it's got no relation to any of these really. It's not a projection of any of these. In the same way that this one was a projection of that and this one was a projection of that. It's kind of its own thing. It's viewing the model from a certain sort of 3D viewpoint, but as I say, it's not dependent on any of these other views. So the way that we're going to place that is we have to go into this first tab at the top of the screen, which I've been informed by some people on their systems doesn't say drawing on the tab. Mine says drawing, that's the label of that tab. Other people's, I think they're slightly different versions of SolidWorks, say things like view layout, I think. But either way, it's the first tab that you encounter at the top there. One of the first icons in there should be this one, model view. And it kind of does what it says. You can see in the description there, adds a single view based on your existing part or assembly. So yeah, that's kind of what we want to do. Click on model view. It then says basically you've got one part file open currently. Is that the part file that you want to create a view of? So in our case, there is only one answer, yes, because we don't have another part file open. So offset link there. So I'm going to go on to the next menu. So I'm essentially agreeing to that. And then what happens is, again, we kind of experienced a bit of this, I think, when we were doing the tile lever drawing. The system's drawing a rectangle to the size that this view that I'm about to drop of the model on the sheet is. So that's not particularly helpful for me. I'd like a preview of what that view is going to look like. I don't just want to know the size that the view is going to be. So click on preview there. Then you get a preview of what that view or that viewpoint is actually going to look like. So we're looking for a 3D style one, and the way that we find it is by clicking through all these different views here. And hopefully you can see from these icons, that one there, which is the isometric viewpoint, is the only one that sort of appears to be 3D. So the icon itself kind of tells you that. So that will do for the time being. So we're just going to click on the sheet where we want that view. And then with the view still selected, and we can tell it's still selected because the rectangle around the view is coloured in this pale blue colour, which means we've still got this view selected. We're going to click on that icon, which will allow us to reposition essentially our camera that we are looking from at that view. So we want to kind of rotate our viewpoint slightly to match the drawing that we're kind of working to. So let me see if I can get the drawing and this on the screen at the same time. Yeah, I think that's working. Yeah, it's not disappearing. And with that view still selected, so I deselected mine momentarily then, but I've reselected it. Click on that icon, 3D drawing view, and then click with your left mouse button and hold down, and you can drag that view around on the actual sheet itself. So we're trying to match what we're seeing on the reference material. Yeah, somewhere there is approximately right. So when we're happy with that viewpoint, click on the green tick. And then the next thing that we're going to start to address is the fact that none of these views are shaded currently. So again, with this view selected, if you happen to deselect it, you can reselect it by clicking on the rectangle that appears when you go near it. So click on the rectangle. I've now reselected this view. In the left hand side, all the setup options related to that view become available, so you can see them all here. One of them is display style, which we kind of played around with when we were actually creating the part itself, we switched into wireframe mode. So you can see that shaded with edges, which is the default that we create these parts with, is available there. So I'm just going to switch over to shaded with edges. And then I'm going to do the same thing for this first view that I dropped. So select the view by clicking on the rectangle that appears around it. So now that view's selected. Switch it to shaded with edges over here. And because that is the parent view of these two projected views, they also change as well. So they follow the display style of their parent. Now you can override that, but that tends to be the method that you want it set up with by default. So there's one last thing in terms of these views that we have to kind of sort out before we can move on to adding some dimensions and annotations to them. And that is their scale on the sheet is slightly different to the reference PDF again. So these views on the reference image or the reference PDF seem as if they're a little bit bigger on the sheet. And if we want to confirm what scale this sheet is shown at, we can kind of zoom into the title block, and yeah, it's at 2:3, so a scale of 2:3. And then ours, if we do the same thing, is at 1:2. So we want to change the overall sheet scale. So we're not going to do this for each view, because there's an overriding scale that all views on the sheet will default to, and it's that we want to actually change. So what we're going to do, we're going to deselect all views, because you can see I've still got this view selected. So you can do that quickly by pressing the escape key, kind of the same way that we do when we're in sketch mode and we want to get out of the tool. So just press the escape key. So you've got nothing selected. And then what appears on the left-hand side here is essentially, it's still erroneously called the feature manager, although it's arguably the drawings manager now. So the makeup of our sheet or of our drawing is shown there in the order that we created it. So you can see initially we came in and we told the system we want a sheet format. So that is the ANSI A3 landscape sheet that we defined. And then we came into the actual sheet itself and we dropped an initial view. So that's drawing view 1, the first one that we dropped. And then we did a projection away from it. So this little icon here represents a projected view. So that was drawing view 2 there. And then projected again, that was 3. And then we did a sort of individual view up here on its own, that's 4. And then right at the top level there, there's something called sheet, which kind of encompasses everything. So it's that we want to modify, the actual sheet itself. And that will kind of, any change that we make there will run through into the sort of child features. So if we right click on the sheet icon and go to properties, then that takes us into the actual sheet setup itself. And then I forget what I said, 2:3 is what we want to set this to. So you can see there the sheet scale 2:3. And then just to confirm, for all these drawings and all these drawing activities that we're doing, we're going to use third angle projection, which I'm assuming you covered all that with Saj, what the sort of difference between first and third angle. But as if to illustrate it, what I'm going to do, I'm going to apply this scale change so you can see the effect that just had. You can also see that I'm going to have to click and drag some of these views kind of back into the sort of most sensible position, which you can do just by clicking on the rectangle around them and just dragging them around. What I'm going to do now is I'm going to switch my sheet to first angle just to illustrate the difference. So you don't have to do this, but I'll switch from third angle to first angle, press apply, and watch that view and that view. There you go. So you can see as I project away this time, the actual part essentially rotates in the opposite direction. So I end up looking up from below onto the underside of that lower kind of tube shape. And the same here, it kind of rotates, so I end up looking from this direction. So first and third angle is kind of the direction that the view rotates as you project away from the parent view. But we want third angle for all our drawings, so I've set that back to third angle now. So I'd say in terms of placing views and setting up the views in terms of their appearance and scale, we're kind of done. So this first tab, which is all related to creation of new views of the model, we kind of don't need to be in there anymore. What we're going to do next is we're going to start putting dimensions on this model. So we're going to move it along to the next tab, at least on my installation. I think, again, once I was made aware of the differences the other week by a few students, I kind of looked on the internet, and I'm sure I've seen the drawings set up with an extra tab slotted in between these two. But it's the annotations tab that we should be in. And in terms of adding dimensions to a model, there's two primary tools within here, this setup or this drawings mode that you can use to add the dimensions in. The first one is just kind of the Smart Dimension tool, works very similar to the Smart Dimension tool that we use when we're in the sketch mode. The second one is to import the dimensions directly out of the model itself. So that kind of pulls through all the dimensions in the sketches that we created, some of the dimensions in terms of the depth of extruded features or the radius of fillet features. You're able to just import all of those. So you don't place them manually by clicking on edges. You just say import them all and I'll delete what I don't want. So we're going to use that tool first. And the reason that we're going to use that, and we're going to use it primarily to place most of our dimensions on this part, is that we were pretty faithful to the setup of our reference drawing. So what I mean by that is the method that this has been dimensioned in this reference drawing, we kind of attempted to set up our sketches exactly the same way. And what do I mean by that? I mean little things such as we made sure that that dimension there was displayed as a radius, not a diameter. And I'm trying to come up with other examples here. So that could apply to any diameter. So we made sure that if it's shown as a diameter, we created it as a diameter in our sketches. This one here is quite interesting. So you could quite validly, is that a word? I don't know. But you could have created this to lock the vertical position of that top edge of our sketch there in that keyway from the center point of that circle. But because it wasn't displayed like that on the drawing, we made a conscious effort to make it display in our sketch as it's displayed on this drawing. And we're going to reap all the benefits of being that sort of paying that much attention, because what it's going to allow us to do is just import all these dimensions now. We're not going to have to recreate them when we're creating the drawing. We're just going to do an import. So let's tackle this view first. Let's import some dimensions onto this view on our drawing. So what we're going to do, we're going to pre-select the view. So you want to click on the rectangle that appears around the view. So now you've selected that view. Then we're going to go up to Model Items, click on Model Items. The view's been accepted there, so you can see Drawing View 2. It's been accepted there because we pre-selected it. That's kind of the cleanest way of doing this. You don't have to do it that way. You can drop in here and have this box empty and then click on it. But yeah, pre-selecting's a little bit easier. Then we're going to tell the system where is the source of the dimensions that we want to import. Is it from a specific feature? No, it's not. We just want to bring them all in, everything from the entire model. So there you go, entire model. So we told it where we want to bring them. We told it the view that we want to place them on. And then we're pretty much happy. So the default type of dimension that it's going to bring in is this icon here, which it says marked for drawing. Now, by default, all of our dimensions that we create in sketches are set to marked for drawing. You can have the ability to go in and unmark certain ones that you don't intend to bring through. But we're not kind of getting into that much detail. And the default setup is that the system will just tick marked for drawing for every single one. So that's okay. So then we're just going to click on the green tick and see what comes in. And you can see, as I said, we've got more than we need, and we're going to delete the ones that we don't need and then repeat the operation again on one of these other views. And you'll see this operation gets easier and easier, because what the system will do when you import it on, say, a second view, it will look at the ones that we've kept on this view and not attempt to import those ones. So it's kind of smart in that respect. But what we'll do now is we'll delete the ones on here that we don't want, and we'll keep the ones and just reposition them a little bit, the ones that we do want. So you click on a dimension. If you don't want it, hit the delete key to get rid of it. And then I'm just glancing over at the reference PDF, so I don't want that one. Do I want that 50? Yes, I do. And I do want the 80 as well. If I can drag that one, it's not letting me. So, do I want the 14? Yes, I want the 14. Aha. So I may have to go back and address that. But yeah, we want that one. We don't want the radius there, and we don't want the 20. But we do want the radius 50, but we want to make it like that, so you can see, because that's a radial dimension, there's various different ways of displaying it, and depending on where you drag the text to, sort of has an effect on the arrowhead and how the arrowhead behaves. So yeah, that's essentially the ones that we want to keep for that view. So now what we're going to do, we're going to progress on to the next view, so this one here. So I'm going to click on the rectangle around the view to activate it. I'm going to click on model items. It's accepted that drawing view. You can see drawing view 1. I want to bring them in from the entire model, but this time I want to click on this box here, eliminate duplicates. So that's going to look at the existing views, and any dimensions that have already been brought in, it's not going to add them into this view. So click on the green tick. It will import some dimensions, and then again, it's just a case of doing a bit of positioning and deleting a few of them. So we want to keep that. We don't want that one. We want that one, but I might sort of reposition the text a little bit. We do want that one. And we want that one a little bit higher up. So you get the idea. We do want this 200, but again, I want it sort of pointing at that edge from the outside. And what you may be noticing, if you've got that reference PDF kind of on your screen as well, is the kind of appearance of these dimensions differs slightly. So here's what we're working from. So little things like all the text on the reference PDF is all held to be horizontal. So it's arguably easier to read, whereas ours, when we have radial dimensions, for example, the text is kind of in line with the arrow itself. So all of these little subtle differences, they're defined by something known as the drafting standard. And currently, at least on my system, the drafting standard is defaulted back to BSI. So we set the sheet format, but that doesn't include what's known as the drafting standard, as I say. So we'll tackle that. Once we put all the dimensions on, then we'll tackle their appearance. We'll probably switch to ANSI as our drafting standard as well, and it will kind of cure a lot of that. So I think we've got all the ones for this view. So we'll go up to this top view and do the same thing again. And this time we should get less imported because we've got two views that have got quite a lot of dimensions on already. So I've selected the top view, clicked on model items. Everything should be set up at this point, yeah? Entire model, correct view, marked for drawing, eliminate duplicates. Yeah, let's go. So we want the 50, we want the 20, might try and place that one there. We do want the radius 4, but we want it kind of over here so that it sits in this free space over here. So what I'm going to do for the fillet radius, I'm going to delete it as an imported item. So press the delete key. And then just for this one dimension, although we may use it for a different dimension, I haven't decided yet, is we're going to use the other method, the smart dimension method for placing dimensions. So click on smart dimension, zoom into the feature that you want to add a dimension for. So in this case, it's this kind of radius on the edge of the fillet there. If I can get it to highlight, there we go. And then it will report back that value like that. However, what you're seeing on your screen is probably that dimension is now colored gray. Now I've been messing around with my options in my system, but let me set them back so that they're mirroring what you're seeing on yours, and then we'll talk about why they're set like that. So you're probably seeing something a little bit more like that. So that dimension that we've added through the Smart Dimension tool by default is colored in gray, whereas the ones that we import using the Import Model Items option are colored in black. And that's useful because the system's trying to communicate how they were inserted, because it kind of has a knock-on effect. So the ones that you import direct from the model are known as driving dimensions. And the ones that you place just on the drawing yourself, they're essentially driven, or they're known as driven dimensions, as in these are just reporting back what that bit of geometry is sized as. So in this case, because it's pointing at an arc, it's pointing at an arc edge there, it just reports back that that arc happens to be 4 millimeters. Whereas these ones, because they're imported directly out of the sketches, these are the sketch dimensions. And what I mean by that is I can double click on that 200 and I can edit it from within the drawing. And when I click on, let's see if we can get it to rebuild in real time. When I click on this regenerate button, is it going to move? No? Okay, I'll click on the green tick. There, it moved. So these aren't copies of the sketch dimensions. These actually are the sketch dimensions. So these are actually driving the shape of the model itself. So let's see if I can make quite a drastic change. So 150 on there. Yeah, I might have just broken the model. Oh, there we go, 150. So yeah, that's why the system colors them differently. So that it's communicating that they are different beasts. They do different things. These ones just report back to you what that dimension happens to be, whereas these ones are the actual sketch dimensions. Now, that's not terribly helpful if you're saving out a PDF of this to exchange with someone. Maybe you don't want to confuse them by leaving all the smart dimensions as grey, because I've had that problem in the past where I then get a phone call saying, what's the significance of some grey dimensions and some black dimensions? And I have to then explain, don't worry about it, it doesn't matter. So if you are saving out PDFs and you've got drawings that have smart dimensions on them, which you undoubtedly will, because often the way that you create a sketch isn't the same way that you want to dimension the drawing. In this particular instance, because we've been really kind of on the ball as we created the sketches, it does apply to the majority of the dimensions, but mostly the way that you model things isn't the way that you want to dimension them on a drawing. So you'll use a lot of the Smart Dimension tool. So in order to get that showing in the sort of solid black color rather than the gray color, you have to go into options, which we've done a couple of times, I think, just to tweak little options to do with how SolidWorks works. Click on options, and then it's in system colors. So colors there, system options, colors. And then what we're looking for is something with the word dimensions and driving and driven. And there it is. Dimensions imported, they are driving, so they're colored black. Dimensions non-imported, driven, currently set to grey. So if you don't need that extra information that it's communicating to you there when it's identifying which ones are driving and driven, set them all to black and just OK. So yeah, if you're exchanging PDF copies of drawings, that's kind of the way that I'd have it set up. But it ain't the default. So yeah, unfortunately you have to set that. So what are we going to do next? Let's change the drafting standard. So we'll get the appearance of these dimensions looking a little bit more like the reference material again. So what we're going to do, drop back into options where we just were. But this time we're not going to make a change to the whole of SolidWorks. We're just going to make a change to this particular document. So we're going into document properties, right at the top of the screen there, drafting standard. Mine's set on BSI, but I'm going to choose to set it to ANSI. And you can experiment. You can flick through the various standards and click on OK and see how it affects. So I would argue that ANSI in this case is way clearer, way more legible. It cuts down on all these extra dimension extension lines. It rotates all the text so it's horizontal, so you can read it when you're looking straight at the drawing. Yeah, that would be my preference. So I think we've pretty much done that bit. Yeah, center marks and center lines. So this is what's known as a center mark. You can see it's sort of a big dashed cross shape that's been placed in the center of that upper pipe, if you like, that upper tube. Now, in some of the views that get inserted, this does get automatically added to them to save you the job of putting it in. But in other views, where a tube shape or a cylindrical shape has been broken somehow, so in this one it's been broken by that keyway, it doesn't auto-insert them. So we're going to manually insert one in the center point of this actual kind of cylindrical tube shape down there. So that would be classed as an annotation. It's not just dimensions that are classed as annotations, it's all these other various types of annotations. So you've got things to do with surface finishes, when people are creating welded, fabricated assemblies, yeah, all sorts. Tolerances, center marks and center lines there. So click on center mark, and then the easiest way to add them is just click on a circular edge. So that would be a circular edge, and it will add one to the center of it. Really simple. And then I think, again, just because the drawing that we're working from has one, we'll add one in. There's what's known as a center line there. So again, that kind of indicates it's kind of the partner annotation to the center mark. When you're looking down a tube or end on at a circular feature, you would tend to put a center mark in. And if you're looking at it side on, you would put a center line in. So that kind of runs along the center axis of this cylindrical face that we know is present there. So let's add that in manually as well. So I don't need the center mark tool anymore, so I'm going to click on the green tick there because I don't need it. I've finished using it. Click on the center line tool. And again, the easiest way to place these is just to click on a face that you know is part of a cylinder. So I know this face here is the kind of side face of a cylinder. So if I just click on that, it will find the center axis and it will put a center line in there. And again, I can just click off that and I've finished. I suppose we could put one up on this view, but there's not one in the reference drawing, so we'll leave that one. Before we come to edit the sheet format, I think we'll just address the fact that there's a little additional note that's been added there, which we can do, and then there's a little additional note that's been added there to just clarify that there are two occurrences of that particular fillet feature. So you can see it's saying there's a face here that's got a radius of 50 and there's two of them. So you've got to search around this view to try and find the other one, and it's this matching one on the other side of the part. So that saves you creating two R50 arrows, one for either side. So let's add those in. So let's zoom in a little bit. There's the R50. If we click on any of these dimensions, single click, that is, all the kind of governing kind of options that create that dimension are available to us there. And the one that's returning this label to us, this 50 and this R, is that little bit of text. So the way that you get the R is simple. You just type the letter R. So the system's done that already. And the way that you analyze what an actual value is on this model is you open this less than sign, and then you type dim for dimension, and then you put a greater than sign to close that argument. And then the system interprets that as a little piece of code to go away and analyze the radius of that edge. But we can just add our own text into here. As long as we stay away from whatever's contained within those little opening and closing symbols there, we can add whatever text we need. So 2 times radius 50. So we'll do that again up here and add the little note that we need on this one. So this time I'm going to go on to the next line down below, and I'm just going to type all red fillets. Now I've specifically left mine in lowercase, and that's because there's an option there, a little tick box that says all uppercase. So that's how I tend to set mine up, because at some point I may want to turn it back to lowercase, and if you type with caps lock on all the time, you don't get that option. It will always be uppercase then. So if the option's there with the little tick box, just use it. Yeah, so that looks okay. In terms of the annotation and the view layout, we kind of finished, and the only bit left to kind of fully replicate that drawing that we were given to work from is to modify the actual title block on this sheet. So we're kind of finished with the drawing now, and we're going into editing title block mode, which is a kind of significant different mode to drawing placement and annotation placement and the sort of creation of the drawing content itself. So what we're going to do is we're going to put our pointer somewhere over the sheet format. So this could be over the border there, but in our case we're going to hover over the actual title block. Right click. I'm going to have to deselect this view. So mine didn't work there because I still had views selected. So I'm just going to hit the escape key until I'm sure that I've not got any views selected. And then I'll try it again. Right click, edit sheet format. There. So because I was over the sheet format, that option's available. And then all my views temporarily disappear. And that's because if you look at my kind of drawing tree on the left here, the views kind of occurred after the sheet format was set. So now that I've gone back to the sheet format and I'm actually changing it, the views technically haven't been created yet. So in the same way that when we're modeling things, we can kind of rewind time and go back to a feature that was earlier in the model tree, we've kind of done the same thing. We've gone back to before all the views were created, and we're actually modifying the sheet format itself now. But as soon as we've finished this, we'll OK our modifications, and we will sort of fast forward back to where we were again, which is at the end of our view creation. So they've not been deleted, they're still there, they're just suppressed at the moment. So what we're going to do, we're going to zoom into the title block. So on this particular sheet, we don't want to edit anything about the border, so we're going to stay away from editing or deleting anything from that. It's just this kind of title block area that we want to modify. And primarily what we're going to do is we're going to get rid of a lot of this sort of excess information here that we don't particularly need for our drawing task. So all of this stuff here is to do with management of a drawing department. It's to do with tracking who did which bit of work and what date it was done on, and getting them to initial or sign something so that you have traceability. So that if something does go wrong or something does go right, you can track who was responsible. So there's drawn by, checked by, approved by, manufactured by, and then quality assurance checked by, and then certain cells so you can add your own into there as well. And there's things like material, which is useful as a general rule, but in our drawing that we're aiming to kind of replicate, a lot of this information has been kind of trimmed away. There's extra information that we're going to add in. And when I say information, I kind of mean the third angle projection symbol. So we're going to have to create that ourselves. But the thing to remember in these title blocks is they're just a sketch, essentially. So I'm going to kind of illustrate that now. Just drag this top line out of shape. You can see this is just a massive, kind of not very well defined sketch. So the reason I'm breaking this is to show you that it's very easy to pull these out of shape. So you want to be quite careful when you're editing them. So this is a huge underdefined sketch, and that's acceptable in this case because this sketch isn't going in to create any actual engineered part. It's just created there for the actual look. It's to create the look of the table area of the drawing sheet. So it's not super critical. It's not as if you have to tolerance this. So it is acceptable to leave these sketches underdefined, as the system has. So this is one of the default system formats, and you can see it's totally underdefined. Everything's coloured in blue, or the majority of things. So be careful as you're editing it, is the bottom line. So I'm going to click on undo and get back to where we were. So essentially, what I'm going to do first is I'm going to trim away all of the left-hand side cells away from the cells on the right-hand side, because currently lines such as this pass through both bits of the table. So that's a single line, and it's over here and it's over here. So I want to trim them away from each other. I want to separate the table into two. And we've encountered a tool that will allow us to do that in the past, and it's called the trim tool in the sketch toolbar. So you can see the sketch tab is available up there, so I'm going to activate it. Trim entities is what we're going to use. Power trim is the kind of sub option of the trim tool that I want to use. And this is the one where you can just click and hold with your left mouse button and you just draw a freehand line. And whatever that freehand line touches gets trimmed to its nearest neighbor. So you can see I'm just dropping down through the table. So I'm separating the table into two halves. And then I'm going to stop before I get to the border of the sheet, because I don't want to trim the border of the sheet. So I've done that essentially. And then there's little bits of text from this side of the table that I'm going to recycle and use again. So I can, this piece here, I've still got the trim tool active, so we can all make mistakes. So I'm going to exit the trim tool by clicking on the green tick, because I don't need that anymore. Then I'm going to click and drag on this note here, because I kind of want to use some of that again. So I'm going to put it over there. Do I want to use anything else? No, I don't think I do. So all of this here is destined for deletion. So the easiest way to do that is to do a click and drag. But remember this, if you click and drag from the top left to the bottom right, whatever gets encompassed by your rectangle that you create there, that you're selecting, whatever's entirely inside it gets selected, but whatever's partially inside it doesn't get selected. So you can see that number 3 there is only partially selected. So when I let go, the 3 won't be highlighted. Whereas if you do it the other way, from the bottom right to the top left, whatever is inside that rectangle, even partially, will then become selected. So that's sort of a neat trick, but it's top left to bottom right. You have to get things entirely within that selection box to select them. So now I've got the stuff selected, I'll just hit the delete key. It'll all disappear. So we're getting there. This note, I made the decision to edit it. So in order to edit the text, you just double click on it and you go into text editor mode. So you can just hit the delete key then and get rid of stuff, and obviously retype different content into there. So it's all quite simple, the sort of methods that you edit these things by. I'm happy with the text now, so I just click on the tick to OK the note. and then I can click and hold and drag it into position. So I want it about there. So if I get what we're aiming for on the screen so we can see both of them together, which is easier said than done. There we go. That's kind of what we're aiming for. So we've got that bit of text there. We want to put a sort of line vertically there just to separate off the third angle cell from the text cell there. So I'll just use the line tool, and maybe I'll let it lock itself to the midpoint of that line. Make sure that it's vertical, and then hit the escape key. So that's that. So there's only a couple more things to do. The offset linkage name. So the thought when you're using SolidWorks is that you would save your part not under a descriptive sort of English language name like we have. We've called it offset link. You would tend to use some sort of code number, generally in sort of larger companies that have maybe thousands of different parts. Calling them all a descriptive name gets problematic after a while, because you might have lots and lots and lots and lots of offset links. So the word offset link, then kind of you end up reusing it, and you end up just putting a code after it anyway. So when you save a part, normally you give it a code number. For example, one's from my past, STV10173X or something like that. So that's what you would get in that text box there. You would get some sort of barely intelligible code that your stock system knows exactly what it means, but a human reading it finds it very difficult to interpret. So then what's intended to go in the title box is a more descriptive name for the actual part. So I've kind of corrupted that here because I've called our part offset link, which maybe I shouldn't have done. Maybe I should have called it OL0001 or something like that to illustrate the point. But the general intention of these SolidWorks drawing formats is that you have a descriptive sort of name for it here, and you have the one that your sort of automated stock system knows it as here. So yeah, if you can imagine that. So what we're going to do is we're going to click there to enter some text. There's already a box that's been kind of drawn out for us in the sheet format, and all we have to do is double click on it to change the text. So the font size and everything has already been set. The position's already been set as well. It's just waiting for us to type a more descriptive name of the actual part into the box. Something like that. And then when you're happy with that, just click on the green tick. Because if you click on the enter key, I think you go on to the next line. So don't make that mistake. So there's only one bit of this really left to do, which is the third angle symbol, which it's always a good idea to put into these drawings just to clarify which sort of projection system you're using. So unfortunately for us, we've got to just draw this as a sort of freehand sketch, if you like. So we know how to use the sketch tool. We know how to use the circle type of sketch tool. We know how to use the line sketch tool, although we're going to use a slightly different option for the line tool. So we kind of want to draw it here. And again, you could get a bit hung up on this and dimension it perfectly. But I've done this so many times, I tend to just do these freehand. So circular sketch tool from the toolbar at the top. I'm going to do the external circle first, and I'm going to go near the boundaries, but I'm going to leave a little bit of space because I know I want a center mark that passes beyond the edge of this circle, so somewhere there is fine. Then I'm going to sketch the inner circle, so obviously I want to lock it to the center point of that first circle, so I'll hover over there and click. Somewhere around that sort of scale is about fine. So there's the two circles. Then I'm going to hit escape because I don't want to sketch any more circles, so I'm getting out the circular tool. I want to create some lines, but initially I'm going to create some, I suppose you'd call them projection lines, off to the right here. So I'm going to create some horizontal lines out to the right that give me a reference to begin creating my conical shape when you view it from the sides, because that's what we're drawing. We're drawing a cone. We're drawing a cone when you're viewing it end on, and then we're drawing a cone when you're viewing it kind of from the side. So I suspect when you've done this using hand drawing techniques, this is kind of what you did. You had to create some projection lines first to kind of give you a reference and to ensure that this side view is aligned with this first view. So I'm going to do that now. So I'm going to click at 12 o'clock on this circle. So straight north on a compass there. Click there. Draw a horizontal line to, I'm going to the back edge of my, or to the rightmost edge of my cone shape. So I'm going to go to there. And then just because I can't be bothered to press escape and reselect the line tool, I'm going to put an extra line in this diagonal that I don't really need, but it's just to get back to north on the inner circle, or 12 o'clock on the inner circle. So to there. Then I'm going to put another horizontal line. So this is kind of the other end of the cone. So it wants to go somewhere about there. Is fine. And then I'm going to do that again. I'm going to go to south, or to 6 o'clock on a clock face on the inner circle. I'm going to wait till I'm vertically exactly below that kind of last point that I dropped there, and click. And then I'm going to do it one last time, go diagonally back down to 6 o'clock on the outer circle, and then all the way out until I'm vertical to that uppermost point there, and then click. And then I can start drawing this cone. So I'll put an edge there. That's kind of the edge of the conical shape. And then maybe I'll draw that top one in. Yeah. And then I'll put the front edge in there. And then the back edge in there. So we've got lines there, some of which I do want to keep, and others that I can now delete because I don't need them. So that's what you should be looking at. Then I've hit escape to get out of the line tool because I don't need the line tool anymore. And then probably what I'll do, just to illustrate the operation, is I'll do a box select, but this time I'm drawing a box from the bottom right to the top left. So watch this one. So bottom right to top left, and anything that is within that, it doesn't have to be entirely within that, gets selected. So you see the different sort of methods of box selecting things, or rectangular selecting things. Hit the delete key. I've got rid of all that. So I'm going to have to manually create a center mark in the center of this now. So I'm going to use the line tool. And one option that I don't think we've used this up to this point with the line tool. So whenever we've created lines, we've drawn them from point to point. So the points that we click and specify have been on either end of the lines. There's another way of creating them, which is a midpoint line. So I'm going to click on midpoint line, and then I'm going to click in the center of these two circles. So there. And when I drag out, I get what is described by midpoint. So I set where the middle of the line was, and as I drag outwards, the two sides of the line grow and shrink equally with each other. So I'm going to put one of these in vertically there, click, and then press escape just to see what I've got. Yeah, that looks good. And then do the same thing again for the horizontal one. So line tool, midpoint line, drop the first point in the center of the circles, drag outwards, click, and then press escape. So yeah, that looks okay. Then I'm going to get a standard line, so not a midpoint one this time. And because I've put these two in here, the system wants to align this new line to them. So you can see when I get horizontally aligned with that previous horizontal line, it gives me a little dashed readout there. So it tells me when I'm perfectly aligned with it. When I am, I just click and then click again to place this one. So we're nearly there. Let's change the appearance of this center mark and center line to dashed. So it's kind of different to the solid lines that are marking out the edges of the cone. So I'm going to click on that line, hold down Control, click on that one, click on that one. So I've got them all selected, and then select that option there on the far left at the bottom for construction, and it will change the kind of line font to a dashed kind of center line style font. So 2 more steps. I want to add a little bit of text here in the correct font and the correct size, just saying third angle. I want to move these 2 symbols to the right slightly, and then I'm pretty much done with editing the sheet format. So in order to move these, because they are totally undefined sketches, they have no kind of relations. Well, they have some relations on them, but not enough to fully define them. Let's say I try and box select that one and then try and drag it. Oh, it's actually working. Wow, I'm impressed. I didn't think I was able to do that. But anyway, what I was going to say is there's an easy way to move them as a sort of block drawing, and it's that option there, move entities. Click on move entities, do a box select to select everything you want to move, like that, and then it's just a from and to click. So I want to go from the center of that circle, let's say, and then as I drag, let's try again. So those are all the things that I'm going to move, all the things that I selected. Click down here to tell it what point I want to move from. I want to move from the center of the circle, and you can see it just follows my mouse pointer. So I can move it to wherever I need, and then when I click there and OK the move, so I'm OKing the move up here, they've moved. So that's arguably the safest way of moving them, because, as I say, it is easy to sort of drag them out of position and ruin all your good work because they're kind of not locked in position at all. So you've got to be really careful. Right, let's put the text in. So I could type a note there, but because I want the note to be the exact same font size and style as this one, I'm just going to take a copy of this note and edit it instead. And the easiest way to copy things is if you select the thing you want to copy, hold down Control, and then drag it out to a different location. And it basically just copies it. So I'll try that again. Click on the new one, hold down Control, and then drag to a new location, like that. So you can copy anything in a sketch like that. And I'll place the title and just double click on it and change it to third angle, like that. And again, there's an option there to switch it all to uppercase if that's what I want to do. So that's how I'd kind of ensure that it's all in capitals. Then I don't want to edit that note anymore, so I'll OK the note. I want to delete this excess copy that I created up there. And that's it. I'm kind of done editing the sheet format now. So I've made my own custom sheet format. Now, we're in editing sheet format mode, which is why our drawings have disappeared. And this kind of trips people up a lot of the time when they're getting used to this. You have to OK the edits that you've made in order to get back into the drawing and be able to change the views or add dimensions. And it's that icon at the top right. So it's very similar to the exit sketch icon, you can see, except it's got a picture of a sheet format. So click on that. You're no longer editing the sheet. Those changes have been kind of locked in. You're not able to double click on them and change them anymore because you're not editing the sheet format anymore. You're editing the sheet itself. So we kind of finished there. Certainly replicating that drawing. So what you would do normally is, first thing you would take is save of that drawing. The system may say you haven't saved the part in a while. Do you want to save all, save everything? I'm going to say yeah. It may then say there are views on this sheet that haven't been updated recently. Do you want to update them to ensure their newest sort of revision before you save? Yes, I do. So you can just answer yes to both of those. Then it'll prompt you for a location. I suggest you keep all your drawings in exactly the same folder that you keep their parts in. It just avoids a lot of problems further on down the line. So keep the drawings and the parts together in a single folder. It will give it a default name, which is just the name of the part. I suggest you accept that as well. Again, naming your drawings differently to the parts that they're a drawing of is fraught with problems. So just accept that and save. And then at that point, the chances are you're not going to share this drawing with either a colleague or a supplier or a customer in its SolidWorks format. The chances are you're not going to send them the SolidWorks drawing file. You're going to send them something like, let's say, a PDF. So we'll create a PDF of this now. So File menu, Save As rather than Save. So Save As. And then rather than a SolidWorks drawing type, just change it to PDF. You can see I've done this once already because I've got a copy, but I'll do it again. Click on Save. And then it should just be as simple. It should save it out. And then I think by default, SolidWorks will open up your PDF viewer that you have if you've got one installed on your system. And it will actually show you the result of that. So you can just check out and just see. Sometimes what you've got to play with a little bit is the edges or the lines here might be in a font which is too thick, let's say. So there are a few options that you can play around with before you OK a new PDF save. So I'm just doing it again. PDF options, there's some options in here that you can play with, but hopefully the default options will be okay for you. So you can kind of set the quality of it in dots per inch. You can activate and deactivate certain things. So yeah, you can play around with that, but that will be unique to each kind of drawing that you're creating. Some of them you'll have to play around with that a bit, and others not. So I'll ask it as a yes, no. Did everyone sort of follow? Did everyone sort of understand that, I suppose, is what I'm asking. I mean, if you didn't follow in real time, this will be videoed, obviously, so you can dip back into the video at whatever speed you need to once we finish the session. So that'll be okay. I'll assume we're all right at this point. So let's progress on to something else. So how long have we got now? So we've got about 20 minutes left in the session. Okay. So my intention next was to do something similar but different. So what I'm trying to do is get you into the way of working that will allow you to do the task that I'm going to release on Friday, which I'm going to give you a week to complete. And it's going to very much take the form of this sort of activity that we're doing now. It's going to be a PDF. The PDF will be a drawing. It will be a drawing that I've created in SolidWorks from a SolidWorks part that I've modeled. And then your task is just recreate the drawing as a PDF. So obviously, in order to do that, you're going to have to create the part first. And that's obviously a skill in itself, being able to look at the drawing and kind of design in your own mind how you're going to build the part up in SolidWorks, what features you're going to use, what order you're going to perform the features in. And then when you've got the part finished as you see it, you'll save it, and then you'll go into the creation of the actual drawing of the part itself. And you'll be kind of required to modify the drawing sheet, lay some views out, dimension the views as they're shown on the drawing, and replicate the PDF as near as you can. So that's what I'm trying to sort of give you practice in doing. So the next part that I was going to tackle, and we haven't got the full amount of time that I'd like for this, so what I'm going to do is I've already shared the part itself there with you. So if you want to take a download of that and load that into SolidWorks. Now the nice thing about that is, because I've shared that with you, so I'll just open my copy of it. We receive the task tomorrow. Yes, sort of when the final session of the week has been taught by me, I'm going to then release the task just to make it fair. So everyone's had their final session and then you all get the task at the same time. So yeah, keep an eye on your email, because what I'm going to do, I'm going to post the task in the assessment section of the shoe site. But I'm also going to email out a bulk email to everyone on the course just saying, here's the link to the assessment on the shoe site. So you'll get both. So yeah, keep checking your emails over the weekend is the kind of takeaway from that. So let me load this part up for us. So this is if I can find it. Ooh dear, where did I put it? Here it is. So again, it's quite a simple part. It's using kind of tools that we're familiar with, but maybe using them in a slightly different way, which I don't expect us, certainly in a 5-week solid course, to be in the sort of more advanced modeling tools. This is why we're kind of repeating, using Boss extrudes, using fillets. We used a little bit of Revolve tool, but there are some much more complicated modeling tools that for a 5-week course, it's unrealistic to get up into those sorts of tools. So yeah, lots of repetition of tools that we've used, but using them in slightly different ways. So you can see this part, it's kind of what's termed a pipe connector. So you can see that there's potentially some pipe-shaped objects that fit through these little internal bores, and then there's a kind of cross piece that goes through here as well. So you're free to download that, and the nice thing is you can pull my model apart, as in you can use this bar, or this model bar at the bottom of your screen, and if you click and hold on that, you can rewind back through the modeling process. So again, we kind of covered that was possible once, I think, but it may have slipped your memory. So that bar, if you click and drag on it, you can go all the way back to the start, where I created just a simple Boss extrude shape. So you can kind of see how I modeled this thing up, how I sort of built it step by step. So that in itself is kind of worth just having a little kind of poke around and seeing how it actually was built. But what we're going to do is jump straight into replicating the drawing of it, which is arguably a little bit of a simpler drawing than the one that we've just tackled. And the sheet format hasn't been edited on this because we kind of covered that skill in the last drawing that we did. So it's just create an initial view, which is this one, do a couple of projected views away from it. We know how to do that. Do some sectioning. So there's an aligned section view here that comes from this A section line there. And then there's a section view that's had its alignment to its parent view broken there. So section B comes from this section line. And then there's a couple of just the nice sort of fancy 3D views that we know how to put in there. So yeah, it's nothing that we haven't done, but there's a few skills that it's worth just sort of reiterating, practicing a bit. And then again, I've left the default system behavior on here, which is, clicked on the wrong button there. The smart dimensions are still colored in gray. So you can see which ones I've had to manually insert and which ones have actually been imported from the part itself. So yeah, that's kind of what we're aiming for. So let's go as quick as we can on this one. And seeing as we're looking at the part, we can go File, Make Drawing from Part. There is a drawing file with the same name as this. So my system's clocking that I've already made a drawing from this. And I'm going to say, no, I don't want you to open that drawing. I want to create a new drawing. So you won't get that. Again, I've based this on an A3 ANSI sheet. So we don't have to change the settings there. It should have kept it from the last time that we used it. And again, we've already decided what the primary view is, or what the parent view or the first view is. It's going to be this front one here. So I'm just going to click and drag that one onto the sheet. And then I'm going to, maybe before I do my projections, I might change the display style. No, I won't actually. because I'm only changing the projected display style there. That was a mistake. Oh dear. So yeah, you don't do that. We'll change them in a second. So I'm going to project upwards and I'm going to project downwards like that. And that's it. In terms of the initial view and the projections of it, that's all I want. So I'm going to hit the escape key to get out of that menu. Then I'll set the shaded options because I want these views shaded again. So I'll click on the original one, the first view that I placed, the parent view. Set it to shaded with edges, which we kind of done before. And then because I rather stupidly messed around with this one, it's linked to its parents being broken now. So hopefully yours hasn't, but I'm going to correct that. I'm going to select that view and I'm going to tick that box. Use parent style. And then I might have to do a rebuild. So that's that icon at the top. Ooh, still not working. Might have to do a full rebuild. There you go. So we've got the projected views. Let's put the section views in next. So we're creating views. So we want to be in the first tab. We're not adding annotations yet. And we're certainly not sketching things kind of freehand. So first tab, which on my system is called drawing. I want to create some section views. So section view option is right there. First view, I want to use a vertical section line. So I'm going to choose that. And then I'm going to drag it over the view that I want to section. In this case, I want to lock it into the dead center of that whole part. So right in the center there of that hole through the part will do. So click. I don't want any fancy options for this line. I just want a normal, straight, vertical section line. So I'm just going to OK on that menu. And then I want it projected out to the left away from the parent view there. So I'll click again. So that's that one taken care of. That's kind of done in terms of laying it out. And then I want to create a second section view. So I want to section through the kind of 90 degrees relative to that one. So section view again. This time this one's going to be a horizontal section line. So change it to horizontal. Again, because there's a line of symmetry running down the center of this part, I want to sort of stick my section line to that dead center. So I can just go into the center of one of these hole features and kind of get this line to lock itself onto there. So that's that one. Again, I don't want any extra features, so I'm just going to click on OK. And this one's going to, again, try and align itself to its parent there, which is not what I want in this case. So I'm just going to place it temporarily off the sheet down here, like that. I do that just because it makes it more legible. It's not sort of obscuring any sheet border then. It's just, yeah, a little bit more legible. And then the direction that I'm viewing that section from, which is indicated by these arrows on the section line, is not what I want. I want to view it in the kind of other direction. So I've still got that section view selected. You can see it's highlighted in that pale blue color on the rectangle that's around it. So I can click on this option because, again, whenever you've got a view selected on the left hand side there, you get all the setup sort of options related to that view. So flip direction will do that. So you can see the arrows are flipped, the orientation of the view's flipped, because essentially what I've done, I've taken a knife, chopped this part in half, discarded this bit where the arrow tail is, and I've kept this bit where the arrowhead is pointing towards. So that's what I'm looking at there. And then I don't want to edit the section view anymore, so I can either click on the green tick or press escape to deselect that view. And then the actual view itself, so not the section line, the actual section view itself, I shouldn't have deselected it, but we'll reselect it. So select it again and then right click over it. And you get this menu, which has a lot of other options related to how you might want to modify views. And it's the alignment that we want to break, because we want the freedom to be able to place this section anywhere on the sheet, which you often have to do. It's nice if you can align section views to their parent, but it's not a sort of prerequisite of using section views. If the space on the sheet doesn't allow, then that's what the label is there for. The label that gets attached to the view should give the person who's reading the drawing an indication of where that view came from. They may just have to search around the sheet a little bit to identify where that section line is with a matching label on it. But that's perfectly acceptable. So alignment, break alignment. And then what we should be able to do is just click and drag it to wherever we need it, wherever we've got some kind of free space to accommodate. So we've done those views. Let's just put a couple of those 3D views in the corner, which we should be getting quite good at now. So again, I'll hit escape because I want to deselect that view. I'm just adding just normal views of the model. They're not created from any other of these views. They're just their own sort of self-contained viewpoint of the model itself. So model view. Now I have two parts open, so you can see the behavior of this menu. If I really wanted to confuse things, I could bring the offset link in now and put an image of the offset link on the same page. Occasionally you might want to do that. Occasionally on certain drawings you need to show a different part just for reference. But in our case, it's this pipe connector that we're creating a drawing of, or creating a view of. So click on pipe connector, click next. What sort of view do we want? We want that isometric as our starting point. And then I'll click. And then at this point, I don't want to change anything about that, so I'll hit escape to deselect it. And then if I reselect it and go to the edit menu at the top, I should be able to do a copy and paste. So copy, click in some empty space, and then I'm going to do the keyboard shortcut, which is Control and V. Yeah, and I get a copy there. So that's just an easy way of getting two 3D sort of perspective views. So I'll just change the display method for both of these. So click on the first one, switch it to shaded with edges, click on the second one, switch it to shaded with edges. And then I'm just going to adjust my viewpoint of these two views by selecting one of them, 3D drawing view icon, and I want to be able to see down through those top holes a little bit, just to see that there is actually some that they cut all the way through the part down to the bottom like that. Then I'll OK that one, select the other 3D view and do the same thing. Rotate round so I'm looking kind of the opposite way at the part this time. Something like that. So it gives you a good indication of what the overall shape of this part actually is. So we've got both of those. Yeah, so I'm reasonably happy with the views now. So then we'd move on to kind of annotating them in various ways. The sort of main one being adding the dimensions, obviously. So let's go into the annotations tab. Let's try doing some imports. So let's import some dimensions onto that view at the bottom first. So I'm going to zoom in a little bit. So I've pre-selected the view again. Pre-select the view, click on model items, and then drawing views being accepted. Where do you want to bring your dimensions from? The entire model in this case. Everything else is set as we need it, so click on OK. Yep, so we've got more than we need, but it's just a case of positioning the ones that we're going to keep, deleting the ones that we don't need. Do I need that one? Nope, I don't need that one. Don't need that one. Don't need that one. We'll probably reposition that one a little bit. And then don't need these two either. So yeah, something like that I think is okay. Yep. And then again, we'd go through the other views, we'd kind of do the same operation again. I'm just searching for one that on the reference image is a smart dimension. So the wall thickness for whatever reason, wasn't importing. So that is defined within the shell feature. So there's a shell feature that's been used in this part. So I'll show you it as it comes into being. So the part at one point was like that, solid, and then the shell feature was applied to it, and it hollowed it out and gave it a wall thickness. So obviously that shell feature has a wall thickness stored within it. There it is, 3 mil. But because that kind of wasn't created on a sketch that was on a plane, when you're trying to import that sort of dimension into a drawing, it doesn't always get applied in a location that is that legible on the drawing. So what I had to do was not accept that as an import, as a model item, and just use the Smart Dimension tool and just add it in myself. And that's why on the reference image, that one is shown as grey. So that one specifically, and a few of the others as well. But I've left the default grey and black colour on that PDF just to illustrate to you, really, which ones I've had to manually import and which ones I've actually, or manually create, sorry, and which ones I've actually used the model items to import. So this has got a more even split. The way that this was modelled didn't lend itself always to just importing the dimensions. They either weren't clear on the drawing or they were just in the wrong location. I wanted them attached to another piece of the drawing. So I think, unfortunately, we'll run out of the time for the session. But yeah, we got a decent way into that. And I think we kind of got a good handle now, hopefully, on kind of the procedure that you've got to go through. If you're supplied with a part drawing, and your task is at the bare minimum to model it up, you should kind of have the tools to kind of pull it apart in your mind first and kind of decide on what order of features you're going to use to create it. And then once you've got it created, the kind of steps that you've got to go through to actually set the drawing of it up and import the views into the drawing. With that in mind, let me check and see whether I've given you the link to all my other SolidWorks videos. Yeah, I have. So there's further SolidWorks videos. There's a link there, which I think I've got some drawing stuff in here. Yeah. So these, if you get stuck as you're creating your drawings, those 2 videos, which are my videos, so I've made them, they're good. They're sort of an hour long each, but the beauty of them being on here is that you can just flick through to the bit that you are interested in. So you can see what's kind of been done on the sheet, and you can flick through to the bit that you're stuck on, and then, yeah, you get the idea. So they're quite useful in terms of that. All those link to further SolidWorks videos are videos that I've made in previous years for similar sorts of modules to this one. So should give you some good sort of help. So unless anyone else has got anything major, I would just say, as I say, keep checking your emails either over the weekend or on Monday morning, and you should get that group email sent out. And I'll put you a link to where the assessment is and just whatever details you need for that as well. But you'll get a week to get that back in. Is that okay? So I'm going to sign off. Okay.